All right, so let's go ahead and take a look at our first example. Let's consider the random variable x, which is the value on the ball drawn from the bag to the right. So in other words, we're going to select a ball at random from the bag that we see on the right-hand side. We could get a 1, we could get a 4, a 7, and there's a different number of uh, balls in there with uh, a 7, for example. There's a different number of 7s and different number of 1s and different number of 4s. So what I want to do is I want to create the probability distribution corresponding to this random variable. In other words, the variable of interest. Let's recall that a distribution is simply a table or graph which will state all possible values. So we want to make sure that we consider all of the different outcomes for my random variable. So all possible values of the random variable. And then we're going to go ahead and find the corresponding probability for that random variable. So let's go ahead and get started. If the random variable is the value on the ball that I obtain, then let's go ahead and recall that when we see big X equal little x, that means in words, the value on the ball is and then little x corresponds to a specific value. So I'm just going to go ahead and say one of the values that I could get, in other words, one specific value that I could get is if I draw this ball right here, the ball with number 1. So the way I'm going to go ahead and write that is I'm going to write my random variable, or capital X right here, random variable, could be 1. Then I need to go ahead and find the probability. So how likely is it that the value on the ball is going to be 1? And that's pretty simple because I'm going to get a 1 from this ball, this ball, this ball, this ball, or this ball. And therefore, we can see that there's 5 different ways that I could get a 1 out of the total number of balls that is in this bag. And there's actually 10 different balls in the bag. So there is a 5 out of 10 chance of getting a 1, which is 0.5. And that is it. That is what a probability distribution is if we do it for every single value that we can obtain. So let's move on to the next one. Another value I could obtain is the value 4. I could get this value 4. I could get this value 4 here. So there's only 2 different ways. So in other words, my random variable could be 4. And so there are 2 different ways for that to occur. And that gives me 0.2. Finally, the last value that I can get on that ball is going to be the value of 7. So my random variable could be 7. And the number of ways for that to occur are 1, 2, and 3. And there you have it. We have my distribution. I know it's a distribution because I've considered all different outcomes, and I've also gone ahead and found their corresponding probabilities. So here we see the distribution as a table, but on the right-hand side, we see the distribution as a graph. And so notice that on the x-axis, we have the possible outcomes. So notice it's little x, and we have a possible outcome of a 1, a 4, and a 7. Notice that at 6, there's no line going up because that means that 6 is not possible. If you say, how likely is it that x is 6? Then all you got to do is look at the height. There is no height there, so that means that the probability of your random variable being 6 is 0. And that makes sense because there is no ball in this bag that has a 6. Neither is there a ball in that bag that has a 5 or a 3 or a 2. However, we could get a 1. And notice that the 1 goes up. There's this vertical line, 2.5. And that's the value here, 0.5. So the y-axis in this case, the f of x, corresponds to the probability. So when you see something like this on a graph where X is the possible outcomes and the Y variable is the probability, the Y axis is the probability, that is a distribution. Okay, they're the same thing. So how you choose to describe them doesn't really matter. All right, let's move to checking that this is a valid distribution. So notice condition number one, for every possible value, we have that the probability is between 0 and 1. So let's just go ahead and see condition one. So for each x, for each little x, we need to have that the probability that my random variable achieves that specific value of x is between 0 and 1. And we can see that, I mean, we have eyes, just kind of go through these right here. All of those numbers are between 0 and 1. So we can go ahead and check this one off. If you have a graph, then what you want is you want all of the bars to be at 0 or higher. And we can actually see that here. Technically, you don't want to go above 1, but we'll rarely see that. All right, let's check condition number 2. Let's change to this orange color. So condition number 2 is a little bit strange. It's basically checking if you sum all probabilities, do you get the value of 1? And that's actually pretty easy because all you're going to do is you're going to take the probabilities on the table here. So 0.5 plus 0.2 plus 0.3. And you can go ahead and check that that is in fact 1.0. So that is a probability distribution. All right, so this was our very first example, very straightforward, on a random variable and describing its probability distribution. Join me on the next video for another example.